And if need be, I do have the PowerPoint up here, and you just have to give me a whistle or a nod or a wink, or just say, Bob, next slide, and then we can go to the next slide.
Yeah.
Good. All right. So what we're going to do at this point, because we have such a large group and we're delighted that you're all here, is I'm going to ask you to go ahead and stop your video. I'll go ahead and stop mine too. And if you have yourself unmuted, I'm going to go ahead and ask you to go ahead and mute yourself. So if you know how to mute yourself, it's over on the lower left. And I'm going to go ahead and, well, maybe I should keep talking because we're not quite ready. All right. And if I call your name, it looks like you don't know how to stop your video. Ron, do you know how to stop your video? There you go. Thanks, Ron. Ramesh, thank you. Sarinda, you know how to stop your video?
Okay, one question, Bob.
Go ahead, sir.
It says share. It says move the copy of this presentation to the cloud to share.
I'm not sure. What'd you say again? It
says share. It says move your copy of this presentation to the cloud to share.
No, that's not what you're looking for.
Okay.
It should be share screen. So on Manuel, go ahead and stop your video. Bob Farkas, if you could go ahead. Do you know how to stop your video, Bob? So on the lower part of your screen, it should say the word share screen. You see it on the bottom there?
And that's on the that should be on
the Zoom itself. Michael, do you know how to stop sharing your screen? I see you got it darked out, but it still shows you're sharing your video. Michael Burnett.
Okay, well, here's the question. Do you see me, Bob?
I can see you. Yes, sir.
Okay. Now that I've got the thing up on the screen, so can you see I'm flipping through it?
No, I still see you. So what you need to get back to the Zoom. So if you want to minimize that, the slideshow, and then go to your screen there, the Zoom screen, and scroll your little mouse along the bottom of it. In the very middle, you should see the word share screen. Should be unmute, start video, security, participants. Do you have your Zoom as full screen right now?
I have it as full screen. I believe it is. Security, participants, chat, share screen.
Share screen. Click on that.
Okay. It says desktop 1.
I don't know what that means, but yeah, try that. And I'm not seeing it, so that didn't work.
It's like I've got to do system preferences here.
All right. We're going to call an audible. I'm going to share my screen. Okay, Paul?
Okay.
All right. How's that? Can you see that okay?
I can see that just fine.
I'm going to mute myself. You just tell me next slide and we'll keep moving.
Okay. So welcome everybody. I am new to this Zoom thing. I had to work through all the shutdowns for COVID, so I didn't get to learn all this good stuff. But anyway, we're going to try to head on through it. This is not difficult for almost everybody of you have experience with voting, and so it should be a fairly easy thing to go through. So we'll just start and kind of move through it. If you have questions, of course, Bob is on there, and we'll try to take them, anything that's brought up one at a time. It doesn't take too long. So go ahead, Bob. Yes, this is the Operational Specialty Course, Seamanship, AUXSEA. Of course, is Department of Transportation, United States Coast Guard Auxiliary, and of course, Coast Guard is Homeland Security now, so you can tell this is a little dated. Go ahead. Bob? Yep, correct. You can skip that one too. And I just like to thank those auxiliaries who generously contribute time, expertise. You guys know that. Next. Next. Okay. So again, welcome to Auxiliary Operator Specialty Course, Seamanship, or AUXSEA. The term seamanship literally encompasses the entire subject of voting. Voting, as you already know, is one of 7 courses leading to the coveted AUXOP rating and award of the badge. Next. Okay, the study guide and reference, of course, there is the Chapmans, which, as Bob said, is the Bible of seamanship. I was presented a Chapman when I graduated from the Coast Guard Law Enforcement School in 1974. Those things have been around for a long time. Everybody depends on them. The reference text, any version of the Chapman seamanship, they're all good. We're going to try to study the same topic in study guide and in Chapman's. I did go over the study guide several times, so if you did, you probably are up on that. The final exam will be based on the study questions in these chapters, so of course that means pay close attention. Next. Bob. Okay, terminology of the boat. Everybody knows that the bow is the most forward portion of the main hull, the pointy end, and forward means anywhere towards the direction of the bow. Ahead, that's a full motion relative to the bow. So of course the ship was moving ahead. The motion is moving relative to the bow, and the stern, of course, is the aftermost portion of the main hull, the back end of the vessel, the blunt end for most ships and boats. Next. Aft, of course, is the direction of the stern towards the back end of the boat. And astern, of course, is the direction of the hull motion relative to the stern, which means you're backing up, backing motion relative to the bow. Sides, looking towards the bow from the stern on either side of the keel. The right side is always the starboard. Your left side is always the port. Next. First terminology. There are no right or left sides on the water. Again, it's only port and starboard. Beam, that's the widest point of the hull, gunwale to gunwale. A thwartship is any measurement made from one side of the hull to the other at 90 degrees to the keel. So it means you can measure that anywhere you want, up or down, as long as you're measuring cross, that's a thwartship. Next. Terms denoting the hull shape. Shear, the curve or the sweep of the deck from the bow to the stern of a vessel when it's viewed from the side. And we're all used to looking at that. And flare is, of course, the outward curvature of the sides of a boat near the bow, looking head on, which helps to keep the vessel's decks drier. And of course, that's usually on a motorboat, something that's moving fairly fast. Go ahead. Next. The hull's bottom, it's a flat bottom. It's little or no lateral curvature when you're viewed from either the bow or the stern. So we know what a flat bottom boat is. A round bottom is when you're viewed from the bow or the stern, the sides show a definite roundness or a curving down and inward from the deck towards the keel. Next. Now the V. When you're viewed from the bow, the sides, they slope sharply towards the keel, but they do have a tendency to flare out shortly after the bow and may continue to do so up to midpoint of the hull. And of course, V's are very, very common in our boating public. A deep V, of course, carries that sharp V style much farther aft, and of course, it was designed to give us a better ride. A shallow or semi-V, the V shallows out very rapidly after the bow. And the deeper the V, the softer the ride and the greater directional control, and especially at low speeds. Next. Displacement. When it's loaded, it sits low in the water. The flotation depends on the amount of water displaced by the hull. That means the water is displaced and it's greater than or equal to the weight of the vessel. The displacement Usually it's a slower vessel. A planing that sets up on top of the water, fast moving. Flotation does not depend as much on the amount of water displaced by the hull, but the load capabilities from dynamic actions with the hull's bottom and the water's surface. And of course, as we all know, it has a lot to do with the efficiency, the way it moves through the water. And that's why we design some hulls as displacement hulls and the other ones as planing. If I remember correctly, the Coast Guard's motor, the 44-foot motor lifeboat has the displacement on the front and a planing on the rear. And it was designed specifically, of course, for heavy weather. Next. Bob? Oh, sorry. Displacement hulls. And of course, here's a picture of one of those. And of course, now one of the very common hull, it has a bulb on at the bottom of that thing that makes move through the water a little easier. Next. Okay, planing hull. And of course, the planing hull is designed so that next. The planing hull is designed that so that, you know, as soon as you get a low speed, the hull gets up on the top of the water. That way it's much more efficient. There's less drag. You know the drill. And the trunk that does not extend fully from the gunnel to gunnel, it has walking space on both sides. That's the cabin. Or the raised deck, it does extend all the way from the gunnel to gunnel, and there's no walking space on either side. Those are the two basic cabin styles. Next. Other building terms, the keelson, that's a timber. It's going to also be metal that's fastened along the top of the keel inside the hull. And of course, the limber holes, those are passages that are cut into the area next to the keel for the water to properly flow to its lowest point to be pumped out. The king post is the spoke of the steering wheel that is vertical when the rudder is exactly centered along the keel. And a thwart is the transverse seat that's generally in a rowing craft. Of course, the keelson in a lot of the older boats, that timber, if they would find it one piece if they could, but you know, they did as best they could. Next. The boot top, and that's the general area of the exterior hull at the waterline. Now, a lot of boats for that, they have a little line painted around the thing too. You'll see it often. A thwart stanchion, that's a vertical support, a stanchion for the transverse seat. So if you've got a seat that sits across your rowboat, that's the thwart, and then the stanchion sits underneath it, because if you're heavy like me, it might be too much weight for it. Next. The other boating terms, the boat motions, pitch, that's the up and down vertical motion of the bow as the boat rotates around its lateral axis. Roll, that's gunnel to gunnel motion of the hull as it rotates around its longitudinal axis. And yaw is a swinging motion of the bow from side to side as the hull rotates around its vertical axis. And those, you know, we've been going through this fast because I know you guys already understand most of this, but also we do know that the pitch, the up and down vertical motion versus the roll. Some people, let me put it this way, we've had bad experiences with pitch and stuff. So next. Broach, dangerous boating motions. Broach, that's downhill. That's a fairly high speed. The bow sharply digs onto the surface. If floods are significant, it washes the main decks. And capsizing, what's that? Say again? Somebody ask a question? Anyway, capsizing, that's when the vessel rolls over, bottom up. You almost don't recover from those. And pitch pulling is commonly following a broach and loss of direction control. The bow plunges deep, turns sharply to one side, the vessel rolls and capsizes, vessel violent, potentially lethal maneuver. That's very common. I mean, it's not that is will most often happen on when there are tall seas, and in particular If you're crossing a bar area and you get a following sea that gets too fast for you, you can't keep the thing straight. That's where you get into a lot of trouble with them. That's really common on the West Coast, especially if the farther north you get, the worse those areas get. And of course, pitch pulling does happen. Occasionally, the thing will broach, and it also happens to Coast Guard boats. Once in a while, they get into the same kind of trouble, and they end up doing end over ends as well. But of course, they were designed to recover from those, so and most other boats are not. So first off, the idea is to avoid doing it. Next, sailboat configurations. Identification depends on the number of masts and the sails and where they're placed. The graphics which follow are highly simplified examples. I know that everyone on this has seen a sailboat and some of the different riggings that are out there, but we'll go through them. And of course, for the test at the end of the chapter and at the end of the course, these are the things you'll need to know. So next. Catboat configuration. That's the simplest of them. You know, you could be even a rowboat. A lot of rowboats will have this set up as make it a sailboat as well. But it's a simple boat, single mast, one mainsail, usually in the front, and very simple. Some people are really good with these things. They even race them. But this the catboat design. Next. Sloop configuration has the mainsail on a jib, and that's really common setup for sloop. It's again, the mainsail on the jib and only one post, and it's forward. It's usually mounted forward in the boat. Next. The ketch configuration. Of course, it has the two masts, and the smaller one is in the rear, the aft, after the mast, and it's head of the steering station. And again, that's what separates the ketch from the other is you notice where the steering station is, and where the aft mast is. Next, the yaw configuration has two masts, and the smaller is behind the steering station. So as you can see in the diagram, where the steering station is ahead of the rear mast. Next. The schooner configuration, you have a main and a foremast, at least two masts. The main aft is taller, the foremast is forward, and it may carry a lot of sails. Depends on the configuration of the schooner. Next. Seamanship, the boat building materials. We're going pretty fast here, guys. The 5 materials are considered, of course, are fiberglass, wood, steel, aluminum, and fabric. I think we're considering Kevlar as part of the fiberglass group. But those are the five main materials that we're building boats out of these days. Next.
I've noticed you're going out of order on the question.
Say again, please.
For each chapter, I noticed that whenever you were going over the different types of characteristics of sailboats, that was on 114.
Mhm.
And I'm trying to keep up.
Oh, okay.
Hey, George, if you do got more questions, go ahead, type them in the chat, and
Okay.
I can answer them there.
Okay.
Okay. Fiberglass definition, of course, is strands of glass, and that's a synthetic glass, by the way, and it's saturated with resin, and it's allowed to properly dry and cure. And those are the two variables there is dry and cure. Next. And the types of fiberglass, actually, they usually use all of these. But you have the fiberglass mat. It's like a cloth, a little heavier. Then there is fiberglass cloth, which is kind of is smoother. And then there's woven roving, and then there's the chopped strands. Now, typically, when you're laying up a boat that's fiberglass, of course, we get into that a little later, but usually you start, with the gel coat, which is the outside, and then you add some mat to it, and then, usually the front of the cloth, and then you add some mat on top of that, then woven roving, and of course, between each one of those layers, you saturate it with the resin or the epoxy, whichever one you're using, and keep laying it in. That way, you have several layers of it. One is for they're all for strength, but the woven roving, that's a heavier fiberglass mat. It adds a lot more stability to it. The fiberglass cloth is smooth. It kind of allows it to finish up easy. And the mat, it depends on the situation. Chop strands. Some of the boats are constructed now where they don't even use the other ones. They just take a blow gun and blow the strands in there. Next.
Paul, which one of these, when you built your boat, which one of these did you use? All of them?
Used everything but the chop strand. We started with, of course, the first thing you do is wax the mold, and then you start with the layer of resin. We were using epoxy, and then the fiberglass cloth gives you the smooth outer, and then we did some fiberglass mat, but then the woven roving, but down in the deck and or the on the sole, the whole bottom of it, and then kind of finished off with a little more of the mat. The only place that really used mat was in edges and place, or not edges, but corners and things like that, where the other woven couldn't reach. The mat's something you could kind of press into place. The chop strands, you can't. I didn't have a gun, so we didn't use that. But the truth is, this was in 1971, actually. And this was a 18.5-foot canoe, and I'm still using the thing, so it holds up really well. Next. Okay. Now, fiberglass, of course, is the most popular building material. And of course, the big reason is because of ease of maintenance. But it's also a material that it doesn't take a huge amount of skill to work with it. The things that you have to be careful of is making sure you mix, the hardener correctly, so that you want it and you want it to dry, but you don't want it to dry too fast, because if you mix a little too much of the hardener in it right away, it'll set up in your bucket before you even get it in place. So those are the things those are the variables that in building using fiberglass that and of course, when you're doing that in an industrial location, you've got it all down pat. You don't have to worry about it too much, but it's a very popular building material. You can do an awful lot with it, and of course, it's easy to maintain. It doesn't rot. It doesn't, and if you get a good gel coat on it, that gel coat will last just as long as the boat itself. And an awful lot of time, it may outlive you. And they're now, they found that, fiberglass, they've got enough experience with it that they don't have to make it really heavy. They found that they can get by with a lot less material and still have the same strength and resilience that we used to. I had a sailboat that was built in 1968, and that sucker was heavy because they put a lot of woven roving in it. They even put composite in part of it in the bottom and stuff, and and right now that sailboat, it's actually over top of the entrance to Raging Waves Water Park because they bought it and put it up there as a display. So anyway, next. Terminology. The fiberglass hull, again, that's composed of the matting, the roving, the cloth, and the strands of the fiberglass when it's saturated with the plastic resin. It's very similar to a steel reinforced concrete. And there is something, when I was going over this, I was wondering, there for a while, they were building some reinforced concrete sailboats, but I haven't seen much about them lately. They were popular for a short time back in the 80s, especially among home builds, but that seemed to went away. And I think part of the reason is it's, fiberglass is just so much easier to work with than building a frame out of steel and then building a mold around it and pouring concrete into it. So anyway, fiberglass is, that's the, and of course now, I guess it's kind of in the fiberglass family, but the stuff they're using for Kevlar, they're building racing canoes and stuff out of Kevlar, and I think they're building some sailboats out of it as well, which gives you something that is incredibly light and incredibly strong. And it's, again, it's very easy to work with. You can mold it into so many different shapes and styles that it's a brave new world, I'll put it that way. Next.
Oh, Bob is asking how many layers of fiberglass materials does a boat hull have?
Yeah, I think it really depends on the boat and who's making it. And I think that most fiberglass, well, of course, if it's built by the chop method, all they're doing is just blowing in the fiberglass. It sticks to the hull. They're blowing it in until they get to the thickness that they want, and stopping there. And it did mention in the book there that the only one of the issues with that is that you really have to know what you're doing to use a chopped fiberglass gun that blows it in there, because you can get it too heavy or too light, and if you've got leave spaces in there where air gets in or something, then that's a problem, and it weakens it some. But for conventional, let's say with the matting and the roving and the cloth, the matting is a pretty heavy material. By the time you start, again, when you put in the gel and that first coat of resin, that's already a fairly strong material. Then if you add, the cloth, it's a smooth cloth, but it also has a really strong, a lot of strength to it. And then and it's smoother. And then the roving is heavy. And it's kind of like a light rug, that kind of consistency, and lay it down. And by the way, when you put it down, you really have to make sure that it's saturated really well, so it bonds completely with the next layer that goes down. Whenever you, as you say, it's similar to steel reinforced concrete whenever you get done with it, but the thickness, that varies with how strong you want it. Now, okay, I see that nobody uses all chop. Go ahead and Charles, if you don't care, you could fill me on that.
I worked for Sea Ray. I was a land manager, and I'm not saying that they are authoritative by any means, but I think probably typical could be used and certainly could be countered. But in widely speaking, in a modern way, you have gel coat, and then they do use chop for a skin coat. That's used with the vinyl ester resin that promotes bonding to the gel coat and combating blisters. And they let that cure all the way so that becomes a structure.
Right.
And then once that's cured, you could put in different kinds of mat, technical mats, but you could build up a thin layer of mat to add strength and then let that cure, and then they would put in a core. I'm good on infusion, and I like balsa because of its superior properties.
Right.
But the most typical core today is foam. Most people like foam because of the bad rep balsa has. So you put a foam core in, some more technical mat, which is a bi-directional 45-45, 0-90. It's just all different directions to give you an all-around strength. And then maybe you would get woven on the last inside piece, only because woven is there. So if you impact the boat, it holds all the pieces together. So you don't get a big hole, you get a dent, so to speak. When you fracture the fiberglass, the woven will keep the boat from coming apart. Whereas, like if you look at the carbon fiber boats, when they break, they go all the way through and they just fall apart and sink because there's nothing there to hold it together. But woven has that function. That's all I wanted to say. Maybe that might help a little bit.
No, that's fine. Actually, I was kind of hoping that there would be somebody here who had more recent experience with it. So, okay, next. Okay, advantage of fiberglass. Of course, it's impervious to the marine animals and worms and borers, but it's not impervious to the plants and stuff that attach themselves to it, barnacles, that sort of thing. Fiberglass does not rot, of course. And also there are no seams or joints. A long time ago, a few were built, where you had a frame and then you would put fiberglass sheets over it, but it always ended up with seams. And you could never keep those seams from from leaking. So the nice thing about this type of fiberglass mold, it's a one big piece and no joints to leak, no, and the collar is molded in. You don't have to worry about it leaching out or anything, and it's really strong. And again, you can mold it in almost any shape. If you can, whatever you core use for a plug, if you want to make it ripples or whatever else, you can mold it that way. And of course, it is low maintenance, especially as compared to the other kind of hull materials. Next. Disadvantages, it's heavier than water. It readily sinks. And and that's I think it's the Boston Whalers that have a reputation for not being sink, because they have that big core in the middle of it there. But just straight fiberglass, my fiberglass canoe without any flotation in the ends of it, it'll go down pretty quickly. Anything else is just straight fiberglass. It's not going to sink. It's definitely heavier than water. And that, of course, is the advantage of having one with a balsa core or something like that as well. The downside too is that it's easier to cover up the shoddy workmanship. You have to cut that sucker apart to figure out what went wrong with it. Of course, again, if you get people who deal with it all the time, they could look at the kind of break or puncture or whatever and assume some of the problems with it. But I remember a long time ago there was a boat company in Seattle that were building those things, that they decided to build a sail. They'd been building good power boats for a long time. Sailboats suddenly became popular, and so they built a sailboat. And as soon as they put a sling on it to pick it up, the keel fell off of it. So, it's you kind of need to know what you're doing with that. But anyway, so it's easier to cover up the shoddy workmanship. Next. Two kinds of resin. The polyester, it's versatile, easy to work with. It's the handle, it's inexpensive. The epoxy is stronger, it's more expensive, and it is difficult to work with. for me, when we were messing with it, the biggest issue was, was getting the mix right. So it didn't set up too fast. So, you could get it on and, but not get, but enough in that it would definitely cure out, within a fairly, reasonable period of time. But, again, the epoxies are a little stronger. I don't know anything about the Kevlars. I think they're, even better, but, long story short, the polyesters are easier to work with and the epoxies stronger and harder to work with. You kind of need to know what you're doing. Next. Resin added hardeners, the resin by itself, that's the reason it's liquid. It comes in, a liquid drum or whatever, and it'll stay liquid for long time until you put the hardener in it. And once you put the hardener in it, then it'll set up. Again, depends on how heavy you mix it. It'll set up pretty quick. And the dryers, that controls the curing time, because you do need the things to cure properly before you can, continue with the next part of it. And also, the stuff is highly flammable, so you got to put fire suppressants in it. And again, all the resins are extremely flammable. That kind of goes without saying. Next. Molds. The male mold, the plug, exact size, shape of the object to the mold. If you were building, a Viking ship and you wanted to mold the dragon's head on top of it, all you got to do is build something to that, that specific shape, and then you can use it for the mold. And the plug, put the fiberglass around it, make the cavity mold, which is the next version. Let me back up. I don't want to confuse anybody here. The mill mold, the plug, that's what you would use to make your actual mold off of. The plug, that's what you would make into the exact shape you want. And then you make your cavity mold off of that, because then you can lay that down and do a hand layup inside it. You can also blow a chop strand into it. And of course, the gel coat is applied first, and that's inside the female mold. And of course, before you put the gel coat, at least the way we always did, we had to wax the mold first so that the gel coat doesn't become part of the mold, and so that you can pop it out of it. The blowgun process is fastest and smoothest, best results. Again, anybody has more experience with this, I'm very happy to hear your input on it. The molds, a match die, the male and female molds, they're clamped together. They spray the material in and then pop them apart, and there you have it. A long time ago, I used to do a lot of photography work for a company that did dome. Their specialty was blow molding, and they were blow molding kayaks and canoes, as well as a ton of other stuff. Most of their stuff was for the medical industry, but long story short, they could make a mold, they can make a product quickly and very precise. The laminate that's used, between the sandwiches, there's balsa wood, there's foam plastic, plywood. Those are the things that typically they're using nowadays. Next. Okay, wood. Consideration for building for having a boat out of wood. Of course, there's a strength. And again, that depends on what type of wood you're using, but they've been building boats out of wood for a really long time. In 1976, after I got out of the Coast Guard, I worked on a commercial fishing tender in Alaska that was built in 1912, and it was 94 feet long, and it was solid wood. V12 Caterpillar engine in it, a big towing prop. And before I got on it, I imagine I was able to see it in dry dock in Seattle. So I had a really close look at the hull, and I had my long story short, I was able to put a lot of confidence in that boat. But anyway, the strength, depending on the kind that the kind of wood that you've chosen, you put in there, they've only been exceeded in strength in the last 30, 40 years. And availability, of course, we're chopping down an awful lot of the old growth forests, so a lot of the trees are not available, but white oak in particular, there's still quite a bit of that out there. And of course, the workability of the wood, you can do a lot with it if you know what you're doing. And the water absorption, depending on the kind of wood that you put there, it'll absorb it to a certain depth and then stop. And geez, they last a long time. That boat that I worked on in '76 that was built in 1912, I found out just last week that it's still out there. Somebody has it in Port Angeles. So there's a lot to be said for that. And of course, the noise. It says it's the least noisy. I also had a friend who interned. Well, he didn't intern. He worked. His wife was getting a PhD in marine biology in Maine, and so while she was doing that, he went to work for a boat building yard where they built the old traditional lobster boats. And he learned how to build them. He said that one of the reasons that they wanted the wood as well, the wooden boats, was that if the boat is aluminum or steel or any of those other products, you're out there 10 hours with your foot on the rail there, and the vibration is being transported up from the engine, through the boat and to your knee, and the wood kind of absorbs that vibration. So that's why they still use them for various workboats and stuff. So, you have they're strong, and still a lot of wood available. In fact, I'm sitting right now next to a lumber yard here the guy, I've known him for 30 some years, and there's a guy who comes down here from Maine every once in a while, and that's his specialty, is repairing wooden boats. And he comes down here, and Dan will saw him out oak timbers, to his specifications, and he'll load them in his truck and take them back to Maine and do whatever repairs are necessary. And again, they last a long time. Next. And I will apologize because I kind of get carried away sometimes here. So, you can stop me if you want. The hardwoods, ash, mahogany, teak, and oak. Of course, they typically are more decay resistant, and the softer woods of cedar, fir, and pine are less decay resistance. But that's not always true. I mean, there are exceptions to both of those things. Again, it points out. Next slide, please. Okay. Well, anyway, a lot of the yellow pine is still available, and it's harder than, it's considered a softwood, but it's harder than some of the the typical deciduous trees that we consider hardwoods. And of course, here in the Midwest, we've lost almost all of our ash trees. The only thing that's out there now is what's dead and dry. And once we use those up, ash will be gone. Hopefully, our oaks will still be around if we still want to be using them for that. But so anyway, the wood disadvantage, the number one disadvantage is dry rot. And of course, the wood's also highly susceptible to worms and borers. And it does absorb water and relatively easily damaged. If you have a wooden boat and you hit a dock with it hard, and that happened to be a a steel lined on a dock or something, you can do some damage to your boat. Next, steel construction. The disadvantages of steel construction are that it's has a quick deterioration. If you don't keep it painted, you don't keep up with it, then it'll rust away pretty fast. And so you have to be, right on it continuously, maintaining that steel hull and that steel superstructure. My first duty station in the Coast Guard in '72 was on the Coast Guard cutter Pontchartrain. And that was a 255-foot cutter, and it was made out of steel, of course. And deck force, that was your primary job, was scraping and painting, scraping and painting. And in fact, when we finally put it into the dry dock, they were they said the hull was thin enough. They think that the only thing that was holding it together was the paint that we'd all put on, all those layers. But anyway, steel definitely will deteriorate, and so if you don't keep it painted, you don't keep up with it. So it does. It requires continuous maintenance. The advantages: it's the strongest strength to weight ratio. I'm not sure that's true when you consider Kevlar and stuff like that, but I don't think they're using it on large boats nowadays yet. But anyway, for just flat out strength to weight, it can't be steel. It's resistant to impact. It doesn't wear out very fast, and it'll take a lot of abrasion before it's a problem. I mean, it'll withstand a lot of hits. And it is less noisy than anything else but wood. Wood is still the quietest of the materials that boats are built out of. The advantages, the aluminum, of course, is our other major metal that we're using. I don't think anybody's building out of not Teflon, but anyway, aluminum construction. It's lightweight. It's impervious to the marine mammals, but of course the algae and stuff will grow on it. So, and it's fairly easy to form. You can wrap it, or you have a fairly good frame. You can wrap it in different directions and stuff, and do lots of stuff with it. Canoes are wonderful out of aluminum. Next. The disadvantage, of course, of the aluminum construction is that electrolysis. It is definitely susceptible to electrolysis, and we'll get into that a little later. And of course, it's also a heat conductor, and it's noisy. You hear a canoe coming down the river and it hits something, or you hit the paddle in it, you can hear it a long way away. And of course, it does dent really easy. So you do have to be kind of careful with this stuff. But and that's also true with the bigger hull boats. You can put a dent in it pretty easily, whereas a steel boat, you would be putting a dent in something else. So next one, the steering systems. And by the way, what we're covering here, again, this is basically what they're putting on the tests and stuff. We're going on the assumption that most of you guys have already read this. And we're just kind of highlighting the points that they want us to remember. And anyway, steering systems, tiller, a simple rudder post with a handle on top of it by which to steer. And of course, the rudders have been around a really long time. They figured that out when they first started floating on logs and whatever. So and a rudder is, if you're in a canoe, you're using your paddle as a rudder. When you make your J stroke, or you need to steer it again, simple rudder. That's a tiller. Again, the tiller is the simplest of all steering systems. You don't have much that can go wrong. And there's the simple tiller. There's still sailboats and stuff out there with tillers in them now, and even smaller boats. And the tiller, that's, you've got the handle there that turns it, and the rudder is attached to it, and that turns in the water, and that turns your boat. Whichever way you want to go, you just turn the tiller, and the rudder will make it there. The steering systems, of course, the drum and cable, it's a relatively straightforward, it's just, you have a steering wheel, that's drum is attached to the steering wheel. The cable's wound around the drum, and then it's fed through a series of pulleys and the suspension, and then each side of the yoke of the rudder post is attached, and that way when you turn the wheel, it takes up the slack on one side, and that turns the rudder. And you turn the other way, it turns it the other direction. So again, it's a fairly simple setup. I don't know how common it is. Next. The drum and cable system, here's there's, your steering wheel and the cable drum and the quadrant or tiller, and again, it's a cable system. Sprocket and chain is very similar to that, except that, instead of having a drum, you've got a sprocket and chain. I'm pretty sure it's a little more, it's a little more solid than just the drum. And the sprocket chain that's built for heavier boats and greater workloads. And also, and again, there's a steering wheel, and you can see the rack and the cables and the control arm that, goes to the rudder again. And rack and pinion. Most of our cars have rack and pinion steerings now, where they used to have the other setup. But anyway, the steering wheel and bottom of the steering wheel has cogs on it that sits into a flat rack that has cogs in that. And when you turn the wheel, it moves the rack one direction or the other. And of course, there's a cable tied to either end of it. And it's apparently a very precise system. So, it gives you a little more control over it. But again, it's just another, way that to set up the boat to steer. Next. Steering cable, the rack of pinion, the steering cable is enclosed in a conduit, and of course the pinion gear, it's attached to the end of the steering shaft and to the one end of the rack, which is attached to the other end of the cable. And the cable also attaches rudder post for the outboard engine. And you turn the wheel translates into turning the rudder or the outboard engine. I think most of our boats that have an outboard engine, that will still be usable. But anyway, that's the rack and pinion. The steering systems, the gear and the shaft, and that's normally, the gear and the shaft is what they used to put in cars as well, and they still do with some of the bigger ones. And but that's usually not put on a small boat. It's a series of worm and bevel gears. They're attached to a steering shaft, which again, translates the directional force of steering. They use that on tractor trailers some as well. It's for strong, powerful, heavy applied loads, such as those on large ocean-going vessels, or somewhere where where there is a chance of a heavy force, something like in tractor trailers. If you're driving and you hit a curb with one of the wheels, it can jerk the wheel. That's the kind of system that's on it. Gear and shaft. Okay, for larger vessels. Next. Gear and shaft again was for the larger vessels. And then the hydraulic systems, that's similar to the ones found on automobiles. You have power steering in your car. That's typically a hydraulic system. The hydraulic fluid, it's under pressure. Actually, steering cable changes, which are translated into, of course, turning motions of the rudder or the outboard. And of course, that hydraulic, that's also how the brakes on your car are set up. That uses hydraulic fluid, same kind of setup. But the hydraulic systems, you wouldn't typically see that on the smaller boats, as far as I know. I could be wrong. You guys have more experience with that problem than I do.
Alice is wondering, do most pleasure boats have for steering? Do they have the rack and pinion? Alice is asking most pleasure boats. I think she's thinking about inboard, outboards.
I think she probably is, and maybe some of the other people could tell, because I haven't been on anything new in a while. So anyway, and when this thing was written, it didn't say which one is the most popular, so I don't know. So we're all ready to the review questions.
Well, Paul, I can go through these and you can rest your throat for a second.
Okay,
All right, and team, if you want to shout out the answer. Now, some of these questions are the same ones that are in the back of the book. So we're gonna go through these real quick, and anybody has the answer, you can just shout it out. Number one, a sloop is a sailboat with a. Anyone?
Hey,
hey,
Oops, back. Let's go backwards. See if I click on here, it gives the, oh, it does tell us the answer. Yeah, A. There we go. Number two, a fiberglass hull is constructed of strands and layers of fiberglass. How do they keep?
C.
C.
Uh-oh, my computer's not gonna let us do it the good way. See if I can do this one other way. No. All right, number three. So C, anybody else have a different answer than C? Let's see if I can go back here. Saturated with resin. Good.
Yes, C.
Three, on a strength to weight ratio, sheet steel is
A.
A.
stronger. It's good.
I don't have those questions apparently.
Yeah, George, I think they're in the back of your book here. These are different than the ones that are in the book, George. All right, number three. Where are we?
4.
Four. Steel boat hulls. What?
A sounds good.
A.
Yeah, require considerable maintenance.
A.
Oh, that's what we do. Good. The simplest type of steering mechanism for a boat is
D.
tiller. Tiller. Good. Good. Limber holes. This is a good one. You're going to see this one again.
hey,
A.
A.
The curve or sweep of a vessel. This is a tricky one. You really had to pay close attention to this one. As viewed from the side is called the what?
C.
C.
Good.
Shear.
Good. Shear and flare get confused a lot. 8. The outward curvature of the sides of the hull near the bow. What is used that is used to keep the deck dry called the
Flare.
Flare.
right on. The use of two or more different materials when constructing the hull is called blank construction.
Composite.
Composite.
Oh, composite, sorry.
The top advantage of a steel hull is
Fighter.
Fireproof.
Fireproof.
yeah. You'd think you would say it with fire, but they're really looking for quieter, which is
Really?
surprising. First time I said that was a little counterintuitive.
I thought
Alright.
I thought it was wood that was supposed to be quieter.
It is.
Wood
It
is
is.
quiet.
Oh, yeah.
This-
Yes, wood is quieter.
this is-
Yeah.
Right. Wood is quieter. No, that's a good point. But
But
one-
it says that in there, the steel hull is quieter than the aluminum and the fiberglass. That's the wood. That's what they're looking at there.
good. All right. So
what is the portion of the exterior hull of the waterline called at the top?
the boot top you're
Yes, the
talking
boot.
about?
Say again?
Yeah. Yeah. Well, we're going to go real quick. We're going to go through all 20 or 34 questions. So chapter 1, questions number 1. Go ahead, read out your answer. What'd you get for number 1?
Fiberglass and resin.
Strand layers of fiberglass. Number 2,
Fiberglass mat and
Cloth.
Woven
Roving,
and chopped
woven.
strands.
top strands.
right on. Number 3,
Polyester and epoxy.
epoxy and polyester. Good. Number 4,
Hardened resin. Control the curing time.
Fire retardant.
Flame retardant.
Fire retardant.
And the
I have a
hard
question.
and the hard.
I'd like to fit in a question here if I could. It may go beyond this course. It is preventing fires within fiberglass. Is that always a requirement? I have,
That's a question. And you know, we're going to take a break in about 2 minutes here, and I'm going to have Paul answer that.
Okay.
Number 5.
Plug.
Wait, I'm sorry, can we go
Plug.
back to 4?
Number 4 was harden time, control curing time, make them fire retardant.
Okay. I missed the
Number
hard
5, plug. Number 6,
Cavity.
Cavity
mold.
mold.
correct. Number 7,
Color
Build a
finish.
home.
mold.
also the cavity mold. Number 8,
Gel.
Gel coat.
gel coat. Number 9,
Male and female.
Male and female mold.
A laminate in
Laminate.
between.
Laminate.
laminate between. Good. Number 10,
Also,
Plywood,
foam.
Foam, plastic, plywood.
good. And plywood, right. Number 11,
Impervious to marine
Impervious.
borers.
No leaks.
Color can be molded in
Resist bugs.
No seams.
and
Good.
resist rot.
No leaks.
correct.
Easy to maintain.
Right. And the last one I didn't hear is easy to mold. Number 12. Number 12.
Strength and weight.
They can stink.
Straight and weight.
Right. So it's heavier.
And the shoddy workmanship.
Right. Easy to cover the shoddy workmanship. 13.
Hardwood.
Hardwood and softwood.
Correct. 14.
Strength.
Strength,
Availability,
and
decay resistance.
decay.
person at a time.
Well, I can pick on people if you want. Mr. Bush, how about number what are we on? 15.
14.
14. Mr. Bush, number 14.
Strength, decay, resistance, and availability.
Thank you.
Good. Sometimes people won't know the answer. Bob Farkas, how about 15? You'd have to unmute yourself. The downside of this is it takes way longer if I have to call on people. You know, I think I'll just read the answers because we are out of time for chapter 1. So 15, they're looking for the highest strength to weight.
Strength ratio, less noisy, and
Fire
resistance to fire.
Good. I'm going to go ahead and read the answers because somebody
All
said
right,
they
I'll
could.
stop.
No worries. 16, quick deterioration without proper maintenance. 17, to protect against electrolysis. 18, lightweight and pervious to borers. 19, heat conductor, noisy. 20, there's the tiller, drum and cable, rack and pinion, sprocket and chain, gear and shaft, and finally hydraulic. 21 is the tiller. 22 is shear. 23 is flare. 24, you have round like a sailboat, flat, and then the V. 25, displacement is where it displaces the water. Planing, it rides on top of the water. 26, shear plank. 27, the trunk cabin is above the deck, but does not extend to the deck edge. Raised deck cabin does extend all the way to the deck edge. 28, holes cut in frames next to the keel to allow water to flow to the lowest point. You can drain them out. 29, composite. 30, boot. 31, king. 32, freeboard. 33, catboat with one mast and one sail. Sloop with one mast with main and the jib. A ketch has two masts with aft one forward of the rudder posts. The yawl has two masts with the aft one behind the rudder post. A schooner has two or more masts with all equal in height or the after mast as the highest. Finally, 34, the total enclosed space calculated in terms of tons of 100 cubic feet. And that 34, everybody has a challenge with that. 31 again is king. Any questions that nobody heard the answer to?
19.
19, heat conductor, noisy.
34.
34.
34. So this is a hard one. 34 is a tricky one. It is actually the total enclosed space calculated in terms of tons of 100 cubic feet each. So it's a little unexpected. So it's the space, not the weight. It has to do with how much enclosed space there is on the boat.
Yeah, I have a question.
32. Somebody asked about 32 freeboard.
32.
Freeboard. Not
Okay.
free like Leonard Skinner. It's freeboard. And Bob, go ahead. What can I do for you?
17, isn't that supposed to be galvanic, not electrolysis? What's related?
Protect against electrolysis. We'll have to double check that. All right, team, we need to get a break here before we soldier on. Any other questions on the questions real quick? All right.
Thank you.
We'll
By the
see
way,
you.
17 it is correct. Prevent electrolysis, by the way.
Good. All right, team. We will see you back at quarter after, and we will have to blast through the next chapter. Kind of running out of time here. See you all shortly. And someone had a question they wanted to ask Paul. Go ahead.
Yeah, some of these questions at the end of the chapter, they're different in the answers that what you're going over.
Yeah, I saw that disparity as well.
Yeah. Does anybody else get that?
You're going too fast too.
Okay.
I was wondering about fiberglass and burning.
These are different questions and answers at the end of chapter 1.
Is it? All right. Well, I have the wrong answers in front of me then. Sorry.
And how long is our
I'm
break?
confused here.
Quarter after. We'll see you at quarter after.
All right. Thank you.
Hey,
Thanks,
Paul,
Paul. Somebody had a question for Paul? Yeah, go ahead.
is the disparity in the answer key that you have compared to what the book has, is your information newer than the book?
No, I'm using the book too. I'm using the Chapman's and I'm using the course that comes with it.
Okay, I was just checking to see if that could possibly be why there's the difference.
It wouldn't surprise me at all. I'll put it that way. And personally,
This is Dennis Pearson. I've got the same as you.
Say again, please.
The questions and the answers are the same as what you've given.
Okay.
Yeah, mines are different too.
The interesting thing about the aramid force, if someone works with the composites, aramid is being affected by solar, by the sunlight. It needs to be protected from a sunlight or will deteriorate, just like a styrofoam. That's interesting thing to know, because usually we don't pay attention to it.
Now I managed to get my chapter 2 up on my screen here.
Hang on a second, Ben. I'm going to stop sharing. Do you want to see if you can share your screen? Otherwise, we'll share mine.
We'll try it. No, it went away when you did that. We'll do it the way you did before.
Okay.
Yeah. No, we'll do it the way we did before. We'll just share your screen.
Sounds good.
When yours came up, mine went away. So.
Oh, sorry. If you want, I can stop sharing.
No, that's all right. We'll do it this way. That'll give you a chance to kind of regulate me a little bit too. So.
No, yeah, no, it's fun. We have a lot of information on the technical issue about whether the questions line up with the book that I have is concerning, because I know they were talking about updating the class, but it's possible to send out the wrong.
Well, I agree with you. I think that it probably needs, well, again, they're not even talking about Kevlar. And that's just that's a really common thing within the last 5 or 6 years.
Good.
Paul, could you repeat the answer for a gross tonnage of a vessel?
All right, I'm going to go slow. It's a hard one, and I'll go slow. the total enclosed space calculated in terms of tons of 100 cubic feet each. Yeah, it's sort of counterintuitive. We're all assuming it's going to be the weight, but it actually has to do with how much space there is on the boat, because theoretically you could load stuff onto the boat.
Excuse me, on that, in the Chapman's, it says the gross tonnage is 40 cubic feet equals 1 ton.
Okay, well, that's the way I was taught. Has anybody else heard of
That's what I was taught too, so I don't.
The 100 or the 40?
40.
Okay,
Chapman
well,
says 40.
all right, well,
40.
you know, I don't argue with the Chapmans, so this is a typo. This is a
I know,
typo.
yeah, I just.
My definition that I came up with out of Chapman's matches what you gave as 100.
Mm-hmm.
So this is Richard. Some that I've not heard, but something that I use is it's the internal capacity of a vessel measured in tons or 100 cubic feet, possibly 40 cubic feet, but it's the internal capacity is the key thing instead of the weight of the boat.
Yeah.
Right, but you've got 100 also, and so semantics, total enclosed versus internal, those are for my money are fairly similar, but in terms of 100 versus 440, that's interesting that they're different.
If you go to Chapman's page 888, it says gross tonnage, the total interior space of a ship, including non-cargo space, computed at 40 cubic feet equals 1 ton. Net tonnage, and it explains what net tonnage is, but 40 cubic feet equals 1 ton.
So here's the kicker. If it says 40, then that's correct. If you take the test and the choice is if it doesn't say anything in terms of space and it says 100, even though you know it's 40, chances are the old online test is wrong and it also says 40.
Mm-hmm.
Good. All right, we got a minute to go. Somebody asked a question. Who else had a question? Anybody? 31? Nancy, you still need 31 or you're good? No, you got it. That's right. Good.
I got it. Thank you.
All right, you're welcome, Nancy. So this is exciting that we have a good group. It is a little tricky in terms of obviously we're trying to stay on task here. Paul, is chapter 2 about as long as chapter 1, or is it shorter?
It's actually a little shorter.
Oh, good, because we're kind of pressed for time because we've got the other part of this, which is to try to get everybody on the same page in terms of quiz questions at the end. And that's really these quiz questions at the end of the chapter. They really help you get ready for the open book final exam. The other fun thing is it's an open book final exam, and so you got your student study guide there, you got your Chapman's there. That makes that final exam and getting that ribbon a lot easier. All right, I'm going to go ahead.
Is it timed? Is the final exam timed?
Yes. It is. You'll get 3 hours. You won't need 3 hours. You'll be done in about 45 minutes.
Okay.
Bob, I got a question with the Chapman's.
Sure.
With the Chapman's book, I looked it up in Amazon, but they got like an earlier edition, a later edition. They got like different editions. So are they all the same or?
No, what they did so they could sell more books is they moved the chapters around a little bit. So what you need to do is when you are looking for, let's say the subject is anchors and your student study guide says, go to Chapman's chapter 12 and you open your table of contents and they move the anchors to chapter 15 or something like that.
Oh, okay. So
always look for the key words there.
Okay, I got you. Thank you.
All right, it's quarter after. You ready, Paul?
Yep.
Let's go.
Go for
All right,
it.
team. Good questions, all good questions. Please go ahead and mute yourselves now. And we're going to rock and roll here with chapter 2.
Okay, boat maintenance. Go ahead, Bob. Okay, first thing to do is we're pulling the boat out. You support the boat ashore. The very first part of it is to make sure that you're supporting the weight of the boat on the keel, not on the sides, you shore it up. You put the blocks under the keel. They recommend like every 5 feet, but of course that has to do with how big the boat is and how many blocks you need to put under thing. But the one thing that is consistent is make sure that the weight is sitting on the keel. Those the shoring that they're just to keep the boat upright. They're not to support it. Next. Okay, so we're laying up the boat in the fall. Obviously, it's the fall. So, of course, the first thing you want to do is clean the bottom of it off and get rid of all the growth that's been there, algae, barnacles, if you happen to be in salt water, whatever. Clean the bottom off, and then, and of course, you wash it and you drain all the tanks and bilges. And then it says to fill and treat the fuel tanks. And of course, if you, especially with the gasoline we have now, if you fill those tanks up, make sure that you put in a stabilizer, and you can buy that, pretty much at Menards or wherever. But make sure you put in a stabilizer so that your fuel stays, in good shape. Of course, they recommend you change the engine oil, and then remove the battery and perishables. And
That fogging is when you put the oil in the engine, right?
yes, and I don't know. I don't know that I've ever done the fogging. They recommend it. Yeah, I think it comes in a can, and and of course, fogging the engine you have to read your instructions because it would be different on a diesel than it would on a gasoline engine. Different on the way you put it in there. But to be true, well, anyway, we'll go with what they say. And also clean the bottom. Right now, they're talking about when you take your boat out, wash it off every time, like in one of the lakes. If you happen to be trailing your boat west, there's an awful lot of states, Wyoming in particular, that they make you stop even with a canoe and inspect it because they don't want any invasive species coming into their state. So, make sure that whenever you, pull it out, clean it up, and make sure you look at it really close to make sure that you've got, all the stuff out of it, including any biological material that might, affect it. I see the thing says use a non-ethanol gas if you can, and I can see that. I don't know where. It's pretty expensive stuff, but yeah, I think you're absolutely right. I know that gasoline now is a strange combination that doesn't keep long. So anyway, clean the bottom, drain all the tanks and bilges. Hang on there. You fuel and treat the fuel tanks and change the engine oil and remove the battery and perishables. Of course, obviously you want the perishables out of there. So go ahead. Clean the head and the holding tank, pull out any clothes, bedding, PFDs. Of course, you want the PFDs out because they can mold in there just like everything else. Wash it with fresh water, then ventilate everything really well. Next. And the bottom paint chemically slows down and prevents the vegetable growth, the marine animal growth, but you have to match the paint to the boat materials to prevent electrolysis. Now, the bottom paints, basically, I think most of them, are still a copper formula, and it tells the right. Of course, we get a little later in this chapter as well about making sure that you don't get the copper and aluminum, the copper paint in direct contact with the aluminum hull if you have an aluminum boat. But anyway, bottom paint that chemically slows down, prevents the vegetable growth and the marine animal life. And you got to match the paint to materials because, again, it's to prevent electrolysis from being set up between, especially a copper paint and an aluminum hull or something. And also to consider the environment. We're going to try to keep our lakes clean and everything. So make sure that whatever chemicals you're using there are kind of approved for where you're at. Next. Dry rot. It's a wood fungus that's thriving in fresh water, and that is fresh water. It doesn't seem to be as nearly as pernicious in salt water, but on the other hand, if it rains or condensation, that's fresh water. And so if you have wood it is susceptible to dry rot. And dry rot, it has a distinctive odor. It spreads rapidly, just like a mold. And you look for it in damp places. The wood becomes soft like putty, and you can, test it by probing it with your screwdriver or a pocket knife. And if you're going to repair it, you have to remove and replace all the affected wood, plus the adjacent good wood. It's sort of like filling your teeth. They make sure that they got all the decay out of there and into, good solid material before they start putting the new stuff in. Next. Electrolysis. That's a galvanic action. It generates its own current because the current flows from less noble to more noble metals. Now, there is a chart in there about what metals, which ones are more noble and which ones are less noble. But anyway, it definitely flows from the less noble to the more noble. And the less noble metal is destroyed when that happens. And so to offset that, they use a sacrificial metal. Zinc is the common one, and they mount it on the hull, and it protects the valuable parts of the boats. And so instead of it destroying your bronze propeller, it destroys the zinc. Next. And the answer, Alice, I don't know if there are different zincs. I just know that zinc is the most common one, and it seems to be in wide use. The next time you go to a marine store or something, you might ask them that. Okay, there's the electrolytic table. The metals are closer to this table, can be used together. Metals are farther apart, can't. Mercury, of course, is the most noble. Monel is a combination of nickel and copper. So you have nickel and bronze and copper and brass and gunmetal and brass. Long story short, you wouldn't combine Monel with magnesium, or you wouldn't put steel with mercury. So they've got to be close together to be able to use them in the same structure and not have that be a problem. And again, the solution that seems to be the universal solution is to put a zinc plate on there that will take that electrolysis, take the brunt of that electrolysis, and save everything else. Next. Zincs. There we go. There are some zincs. You can see the zinc that's on the propeller shaft, the zinc's on the hull. So anyway, it's attached there. It's used so that the electrolysis will eat that instead of the other metals is there. Next. There we go. And those are just zinc plates, they're designed to be replaceable. How's that? If they're going to be eat up, they're designed to be easily replaceable. So go ahead, next.
All this metal stuff almost sounds like an anode.
Yes. Electrolytic action, not galvanic, electrolytic action depends on an external current. And next. And where that current goes in the water, the metal is destroyed. And the solution to that is to eliminate stray electrical currents. And they're talking too that salt water is kind of a conductor in itself. And so the current goes into the water, that's where the metal. So anyway, that's electrolytic action. It depends on an external current. And so they're saying the first thing to do is to try to eliminate any stray electrical currents that's run around in your boat, which means make sure all the grounds are good, clean. Make sure that all your connections are good, not thing. And I know you're familiar with electrical currents that run on the outside of your battery. If you if you let it sit and it builds up the stuff between it. Anyway, next. electrocution. Stray currents that get into the water, they can endanger materials as well as swimming. And of course, if you swim in, if you're in the Chicago area, you know that they have an electric barrier in the sanitary ship canal that's basically to keep the Asian carp out of Lake Michigan. And so far, it appears to be fairly successful, but it's basically an electric field that keeps them from getting close to it. Now, and it says, of course, all the electrical circuits that are located near the water should be fitted with a GFI. I'm sure you know what a ground fault interrupter is. You know, you can buy them at almost any hardware store. Next. The shaft train. Now, this is on, you know, the old style boat that has a shaft and you know, that's just a, you know, a shaft and a steering. But anyway, the way that's set up is you've got the motor there. You've got to have a way to get the power to the propeller. And so it goes to a coupling. It's a universal joint if it's, you know, if there's any curves or anything. And then there's a stuffing box. That stuffing box, they call it a gland. It's got material in it that you can squeeze tighter or looser, but that stuffing box has to have a little bit of moisture in it. So it's normal to see drips coming out of it. That goes to the shaft log, which you know, goes through the actual hull of the boat, and then the shaft goes on down to there's a strut that holds it in place, and that strut, there's a bearing in that strut so that the shaft can turn, of course, without wearing it out. And then the last thing is connected to is the propeller, and that again, that's that's just a standard setup for a straight, you know, shaft motor, but anyway, the stuffing box is a critical part of it that keeps the water from coming back through the shaft hole and flooding your, you know, your bilge or anything. And of course, the shaft log is what the shaft goes in when it goes through the hull. And of course, the shaft, of course, is just it's a drive shaft like on your car. Okay, and next, yeah. The shaft and propeller are supported by a strut and a cutlass bearing. And now they go in a little bit of detail about the cutlass bearing. But the big thing to understand about the cutlass bearing, that it relies on the water flow to lubricate the shaft. You know, if the shaft was someplace else, you know, if you have a shaft in your engine going someplace, it usually has bearings and relies on oil. These bearings rely on the flow of water to lubricate the shaft so that, you know, it turns freely. Next. Stuffing box. And that prevents the water from entering the boat around the propeller shaft. And it says, you know, a slow drip of water is required to keep it lubricated because that shaft is turning inside that stuffing box still. And basically, that there's a packing material in there, and now it's kind of usually a form of rubber. They gave the name of Navidite or something like that. But and what it is, it's like just like a washer in your faucet. And if it's, you know, too much water comes through, you just tighten down the nuts on the stuffing box and the gland, they call it, tighten down the gland nuts, and that keeps the water from coming in. Next. And there's you know, a close-up of them. You can see the gland nut and the gland, that's, you know, that's like the rubber washer. And then the packing material, and that constitutes, you know, the stuffing box. And so the shaft log, of course, goes through it. And that gland nut, you know, it's a fairly simple thing too. So next. Wow. That's the end of chapter 2. I guess we covered that one pretty fast.
All right, so I'm gonna see if I can stop sharing and bring up the book from chapter 2. If I can't find that. So, Paul, you're gonna have to fill while I find this. Tell us a story quick.
Yeah, well.
How many hours on the water do you have, Paul?
I don't know. I was, um, I was in the regular coast. I was on a ship for the first 6 months of my career. And then I became a photojournalist. I was on pretty much every ship they had and the helicopters and stuff. And then when I got out of the Coast Guard, I worked in Alaska as a commercial fisherman for a season. So there was a little more time. I've been kind of playing around with it ever since, but I haven't been out to sea in a long time. I'll put it that way.
That's cool. But you definitely have over 700 hours.
I would imagine. I actually have a merchant marine document that does. Now that I think about it, it does list how many hours of sea time and stuff, and but I don't think I put anything of the Alaska time even on it. Because the merchant marine document's good for life, but you do have to kind of keep up with it, and I really haven't kept up with it because I don't plan to ever go to sea again, or at least not professionally.
Good. All right. So John, is it Waymer or Weimer? How should I say it? Is it Waymer, John? Asked if there will be a final exam giving by us. Now, how it works, for those of you that have never taken one of these classes before, we will direct you to a website, and it's a national website. It's an open book exam. And like I said, you're given, I think it's 3 hours, but it probably won't take you 45 minutes to finish the exam. And for some reason, let's say you didn't pass, it will tell you which ones that you got wrong. So you can go back and review that. But if you're taking the time to look through your books before hitting the answer button for each question, you probably do pretty well. And that is assuming you're keeping up with all these quiz questions. So I think this time, if you want to, we can go through and pick on people, which I know you're excited. Go ahead. Let's see, Bob, what did he say? A nut holds the prop so it doesn't come off the shaft. The shear pin.
Well, we didn't even cover that. What?
Yeah, I don't know if we missed that slide somehow.
Yeah, missed that slide.
Yeah, well, should I go back to that, see if we can't see it in there? I don't know if it's in there.
Well, actually, it's not that complicated. It's just that, when you put the propeller on, then there's a nut that goes on to hold the propeller in place. And then usually they put a cotter pin in the nut to keep the nut from backing off.
But they also it's a lock nut, and it's backed by a jam nut combined with a key. And the key is what prevents it from coming off. It's slotted, and you press down these metal pieces in the key to prevent, in order to get it off, you have to pry those metal pieces up in order to get the prop off.
Do they call that a castle nut in marine terms, or?
Well, yeah, I'm not sure, but
yeah,
but I've always known it as the key.
Yeah.
So good. So the idea there is your propeller spins, it hits something in the water, and that snaps the shear pin. And if you're lucky, the propeller doesn't get knocked off. It just stops turning because it hits something. Because if it fell off, you'd have to buy yourself a new propeller, and propellers can get expensive. So you would prefer to have that shear pin snap, and then what happens is the propeller just spins freely. It no longer is attached directly to the shaft, so that you don't your engine, even though you still have a prop down there, it spins freely because the shear pin snapped. Anything else with that, Paul, you want to share?
I can tell you a quick story. When I worked in Alaska, there was a guy up there, they called him Wooden Wheel. And the reason they called him Wooden Wheel was he was down at the end of Chatham Strait there, and the pin came off of his it was the propeller, and the propeller came off, and he managed to anchor it up when he again, this is a big fishing boat, you know, like a 32-footer. And so he took his boat ashore and cut down a tree and carved out a propeller out of it and put it on there, and that got him all the way back to Petersburg. And so they called him Wooden. As long as he didn't hit reverse, you know, as long as he had force against it, it stayed on.
Cool. All right, Surendra, I think I pronounced it correctly. So Surendra is asking, how do I document our time? Will it be code 7029 or 7030? So it's on the 7029 form. These are your 99 hours. For, I believe it's 99D for studying, although it might be E. I think it's D, isn't it? Who's our AUX data specialist that's with us tonight?
It would be D for training.
Yeah, so
Right.
you're good. Did everybody get that question and understand the answer? So it's on your 7029, but on AUX data, of course, you do it with the report there. Now, some flotillas, they still have people who are doing the recording for us, but most flotillas with the AUX data too, they want us to fill out our own information.
Does that include study time also? Sorry.
Yes, it does include study time and anytime you're sitting here in class too. So be sure to log that on because our flotillas definitely want to see what we're doing. All right, I'm going to bring up the quiz questions. Anything else before I bring up the quiz questions? All right, and I know how you like to be picked on. So if you don't have the answer to the question, you can just say pass and nothing bad will happen. All right, number one, how about Kurt Brungart? What is the proper way to block up a hull? I know it's a long explanation. You're there, Kurt B. Go ahead, unmute yourself if you don't mind. Or you can just say pass. Yeah, I've had this sometimes where people are they're not able to speak because their microphones don't work. Go ahead,
Okay,
Kurt.
I'm good. I'm Kurt B. Sorry, I was struggling with my little mouse here. You want to put the weight on the keel, but you got to put a block under the keel, so there's ventilation under that. And then roughly every 5 feet, which is roughly what I do with my sailboat, and you want to make sure it's level at the water line, which is easier said than done, but yeah, that's the way you do it.
Good. And I think the reason you want to have it level so it continues to, the limber holes of water continues to drain out like it's supposed to, right?
Correct. Correct.
Excellent answer. Thank you, Kurt. Mr. Wisely, is your first name Bob? Number two, if you're willing, why shouldn't you allow the weight of the boat to rest on the shoring?
Excessive stress and strain on the outsides can cause structural damage, and the sides were not made to support the weight of the boat.
10 out of 10. Excellent. Michael K. This is another long one. You're welcome, Michael. List the layup chores that must be done after the boat is hauled out.
Clean the bottom and wash it, and wash the hull.
Good. A couple other chores. What else do you want to do? Paul touched on these pretty well.
Drain the water system.
Good. And you may want to stabilize the fuel. Want to get any perishables off the boat. I think there's a couple more. Anybody else want to pitch in for this?
Sure, drain the fresh water tank, fog the engine, remove the battery, and
Change the engine oil and filter.
yep, clean and winterize the holding tank, and
Yeah,
winterize the fuel tank.
Excellent. So go ahead.
Remove the plug. I learned that lesson the hard way.
Yeah. Good one. Yeah. No. So one of the big topics that usually comes up in these AUXSEA classes is where do you put the battery? And so one of the things had to do with you put it on a piece of wood, because if you put it, what did they say, directly on concrete, somehow there's a electrical thing that happens. It's not good for the battery. So Yeah, you ground it. So they say you should put up on something like a couple pieces of wood that'll keep the battery from going bad. Good.
You put
All right.
you put it on a piece of wood because the battery will get warm because of the electrical current going on inside of it, and the concrete will get cold and you'll get condensation underneath, and then surface charge will allow it to discharge.
Excellent. Excellent answer. And clean the head. Keith says clean the head. That's a good one. All right, number 4, Gary, I'm sorry I'm picking on people. Number 4, Gary Bushi, what is the purpose of allowing the boat to ventilate when it is laid up?
Prevent condensation and smell.
Yeah, keep it from dry rotting or
And dry rotting. Yes, sorry about that. Yes.
Excellent. No, right on. Les, how about number 5? The 2 types of marine growth are blank and blank.
Animal and also vegetation.
Vegetation, correct. Sarah cannot see number 6. What are the 2 things that can happen to a wooden boat that is not protected against marine growths?
Rot and not sure the second one.
What they're looking for is if it gets a bunch of marine growth, it'll slow down. So the performance.
Slow down. Okay. Yeah. Performance.
Lose efficiency.
Right on. How about Donald Lynch, number 7? How does copper protect a boat's hull? You going to unmute? There you go, Don.
Through galvanic action, it prevents electrolysis and marine growth.
So they weren't really looking for the electrolysis.
It gives off poisonous.
Yeah, poisons the vegetation, the animal growth.
Yeah. So there's, then again, like a lot of things, there's talk about, that it's bad for the environment, the copper, but in salt water, it gives off poisonous salts, which can, keep you from getting a lot of marine growth. Different kind of paints now that the hope is that they can reduce the amount of damage without being quite so toxic to the environment. But if you're doing a lot of sailing, you don't want a bunch of growth on your exterior hull. Let's see, Bob Fires, 8. What should you consider when selecting a bottom paint for your boat?
I'm assuming you mean Bob Farkas?
No,
in the
Bob.
boat.
Sorry, Bob. F-E-R, yeah, go ahead, Bob.
The other metals in the boat.
Yeah.
Yes, the other metals in the boat, because one of the things I want to highlight, and Paul explained it very good, but if you have like aluminum and brass, they're not close to each other in terms of one's less noble and one's more noble. And if you don't have that zinc in there, man, that the brass is just going to destroy that aluminum. Right? But Sergeant, how about number 9?
Also the environment there too.
What was that? I'm sorry.
Also the environment that you're in is the other consideration, selecting a bottom paint.
Excellent. Good answer. Bob Sargent for 9. What causes dry rot?
Exposure to fresh water and salt water can also cause it, and keeping wood in it unventilated.
Good. Yeah, they really focus on the fresh water in the book, but yeah.
It's really a fungus.
Fungus.
Yeah.
Yeah, fungus that thrives in fresh water. Good on. All right. Charles Lang, how about number 10? The first indication of dry rot is?
The smell.
The smell. It stinks. Good. Richard S.
Sorry, I wasn't unmuted.
Oh, no worries. Richard S. List some of the places to look for dry rot in a wooden boat.
The hull, also any of the wood surfaces on the deck.
Good. Paul, what are the garboard strakes? What are those? You there, Paul? Did I lose you? Mr. Burd?
Oh, you're talking to me.
Yeah. No, tell us what the garboard strakes are.
Okay. Wait a second.
Weren't expecting that question, did you? I threw that was unfair. Sorry about that.
I was on the wrong page here. Sorry about that.
All right, we'll get back to you in a second. That was unfair. I threw that at you. R. Colbert, is that Robert Colbert?
Yes, Rob. Yes.
Rob, how about number 12? The dry rot is found. It must be.
It must be eliminated.
Right. Yeah, you dig that dry rot out. And you also got to take some of the good wood around it because you want to make sure you get it all out.
Yeah, and the garboard strakes, that's right next to the keel, is it not?
Yes.
Right.
Just above.
That's a good place to look because you can have a dry rot in that area. So it's Richard H. How do you prevent dry rot? Mr. Hurd? Eric, can you unmute? I'm sorry. Richard, are you still there? I'll keep moving.
Yeah. You could keep it out of your boat, keep fresh water out, and use wood preservatives for all unpainted wood surfaces.
Excellent. So one of the things that comes up in this class is, what if I encapsulated my entire sailboat in saran wrap or plastic? And Paul Burd, why is that a bad idea?
It doesn't allow ventilation.
Yeah, it won't dry out. It'll stay wet inside there, and you'll still get rot. Good,
And
George.
Go ahead.
Sorry, go ahead.
And part of that the condensation is where you would get the water inside there. If it's sealed in tight.
Some people may say, well, let's just wrap the whole thing up in saran wrap, but that's not a good answer. George, what is the difference between galvanic action and hydrolytic action?
Electrolysis action?
No, I don't know.
Galvanic is basically whenever you have a piece of metal that helps prevent rust. And the electrolytic action is, I think, help. Oh, shoot. I can't think what I'm trying to say. I'm sorry.
Don't worry.
Can I help you
Go
out?
ahead. Go ahead, Alice.
Yes.
Fire.
I was going to say electrolysis is two metals in salt water that generate electricity by a chemical process. Think of a battery, like a small dry cell battery.
Doesn't have to be salt water.
Okay, yes,
No.
thank you.
That's galvanic action.
No, galvanic action is two dissimilar metals that are electrically conducted and are immersed in a non-chemically pure water, and it can be connected by if not, what it causes is corrosion. Am I right on that?
No.
What happens with the metal is the spare electrons start leaching out of it, and the metal itself becomes very, very weak because it's breaking down. And how about electrolytic action? You know what they're looking for here, Alice?
I thought it was the generating of the electrical chemical process.
So what they're talking about here, if you remember,
Electrical discharge.
Yeah, stray electrical currents in the water. Good.
That's how they protect dams, correct?
No.
Yes, the dams, bridges. It's quite popular in construction engineering. That's correct.
All right. Dan Lippin, number 15. Current will flow from the blank metal to the blank metal during galvanic action.
Less, no. More
From the less noble to the more noble. Good. How about Jerry Clem, number 16? You want to answer a question here? What is the principle of using a sacrificial metal to minimize the effect of galvanic action?
That one I couldn't figure out. So sorry, I did every other one except the last couple.
Well, Jim Whipple, you want to take a crack at that one?
Sure.
Number 16.
16. Galvanic action destroys the third metal and saves the other two.
Hi, Gibby.
Good. Yeah, the zinc one. So you want the zinc to break, not the aluminum. The other one, so the boat doesn't fall apart.
But don't you have to keep
replacing that periodically so it doesn't eventually get to the other ones?
Yes.
Well, yeah, if you were to lose that zinc or if it were to break down substantially, you want to put a new one on there so that the more noble metal won't start chewing up your aluminum or whatever the less noble metal that you have on the boat.
Right.
Good. That's a little tricky. Good. Keith Rollins, how can you prevent electrolytic action? You there, Keith?
There we go. Am I on here?
Affirmative.
Okay. Electrolytic action. Usually in my class, we talk about keeping your two engines grounded together so that you don't have stray current in the water, but
that's it. You hit it on the head. You're trying not to have currents going in the water. Right on. 10 out of 10. Let's see, Al Krieger, how about number 18? The shaft drive is made up of blank, 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 and blank.
All right. The shaft log, the prop shaft, the strut bearing, strut, and propeller.
Excellent. 10 out of 10. Diane, how about 20? The strut bearing relies on blank for lubrication.
I'm going to pass on that because I'm running out the door to go to work. But can I ask you if you're going to be posting your PowerPoints?
We can send that out to anybody who wants them. Please send me an email. Not everybody wants me to spam them. So go ahead and send me an email. Hey, Bob, it's me. Could you send me the PowerPoint?
Okay.
Tuesday. Where are you? Are you there Tuesday? How does
water, the strut bearing relies on water for lubrication?
10 out of 10. Right on. Michelle, 21. What is used to keep the propeller on the shaft? You got that one, Michelle? You there?
Yes, can you hear me?
Yeah, go ahead. Number 21. What is used to keep the propeller on the shaft?
A lock nut. Most use a nut backed by a jam nut combined with a key.
That's it? Or a lock nut. Also
That's it.
Mike Lalonde, I think I skipped one here. Number 19. How does the stuffing box work? Or maybe we did and I've forgotten already. Mike, you there? I'm trying to give you a spare.
Yeah, I'm here. It prevents water from entering the boat. It surrounds the shaft, holds the rings of the packing material, and it squeezes tightly around the shaft.
Sounds good. All right. Next week, we are going to get into chapter 3, internal combustion engines. You are all invited if you want to turn your cameras on so that we can all say good night. It is 54 after. What was the one question I said? Can we come back to that? Bob Sargent, we're not asking you to sing any sea shanties tonight. Sorry. Maybe next week. All right. But everybody, you can see Bob shared some of his music connections there. Who had a question that didn't get answered? Anybody?
Yes, a lot of the questions and answers from chapter 1 were totally different. So I need to give those questions for chapter 1.
I had one. It's where we talked about a catch and a yawl. And I think in the material or in the presentation, you said it was the aft mast before or after the steering station. And in the questions, when we answer them, it was the aft mast before or after the rudder post, which I think is the right answer. But there's two different answers there. Could you comment on that?
All right, well, let's look at the question. Did everybody else hear the question? Which number question was that? Paul, you got your book right there? Because
I'm looking at my question sheet here, but
Nicholas, you got the book right there? You can unmute Nicholas, okay?
It was question 33.
I can't come up with that power here.
Correct on the 33.
All right, was it chapter 1?
Yes.
Chapter 1.
Chapter 1.
Yeah, 33 was the characteristics of the sailboat types. The well, catboat, you don't want the definitions, but you were talking about the yawl. Two masts with
Right.
the aft, two masts with the aft behind the rudder post.
Yeah.
Two masts with one aft behind the rudder post, and a schooner was two or more masts, all equal in height, or with one being the highest.
Yeah.
What was the question?
I think
If I
this
could
question.
say, if I could say that though, the question was the difference in a catch and a yawl. Because in one definition, they use the rudder post. In the definition that you presented in the material that you showed on the screen, you used the steering station. And so I'm wondering, is this an important question? Should I disregard it, or is it not important, or do you want to
No,
comment?
Get
The
to Renee.
catch has the rear mast mounted a bit forward of the transom. And a
One
yawl,
forward
if
of
it's
the rudder.
mounted any further aft, it's gonna be in the water.
It's
On the
on page
catch.
37 in the Chapman's.
Yeah, you all, well, different versions of Chapman's have it on different pages.
That's right. I forgot about that.
Okay, so Chapman's on page 31. I have 69th edition. And it says, if it is ahead of the rudder post, the boat is a ketch. However, if it is behind the rudder post, the boat is a yawl.
I think it's gotta be the rudder post, not the steering station, because that could be anywhere. I mean,
Right.
yeah.
I mean, I'm a boater. I know that it's the rudder post, that's the line of demarcation. It's just that in the PowerPoint that you gave us, you were calling it the steering station.
Yep. Yeah, I noticed that as well.
Oh, okay. So does that make sense, Paul? Because I'm trying to bring that slide up here.
You need to get the slide.
Yeah, I concur. I think it's the rudder post.
Yes, that's the most accurate.
Hey, Bob, is next week only chapter 3 or 3 and 4?
3 and 4. We're doing
Yeah.
2 chapters per week. We're doing 2 chapters per week. Why does that not work? Oh, it's seamanship. We're doing 2 chapters each week, and that way we can get through the whole program in 6 weeks, which is exciting.
Will you send out the study guide like you did for this class tonight?
You mean the slides in advance?
No, the questions. And where we had the little bit of reading and you could get the answers for the questions prior to seeing your slides?
Well, the idea, that's the one thing that comes up is, should I tell you the answers before we actually have the class? And, that's not going to motivate people to study hard, unfortunately. And so we will talk about the answers during class. But really, if I just sent you the answers, you wouldn't study. And that's not the purpose of the class. And if you could fool around in the book and dig around in there and find out what the answer is, you're going to retain a lot more than if I just tell you A, B, C, or D.
Right, which is what we did tonight. You sent
you didn't study? You didn't study before class?
Yeah, I went through and read and filled out all of these answers on my own before class started.
Good.
So I was basically checking my answers against what you were coming up with.
The study guide that he sent had all of the chapters in it, not just tonight's.
Oh, okay. I have to go back.
130 some
All the questions are different than what he showed for chapter 1.
Did anybody else have all different questions in the back of the book for chapter 1?
I had no issues. I printed the whole thing. It matched up everything you did tonight.
I'm fine. My only question, this is Koenig. The last class is scheduled for 2 September.
Labor Day.
Yes.
It's scheduled for, yes, it is scheduled for Labor Day. Now, if you guys have family plans, family's always first.
No.
Yeah.
That's fine.
Family's always first. So, if you've got family plans, you take care of your family and then you watch the, you watch the recording later on.
No, I'm fine. You said 6 weeks, it would be 5 weeks,
You're right. I'm sorry. 5 weeks. My bad.
5 weeks, okay.
Screen
No, I'm
share
fine, I'm fine.
on that.
What's the corresponding part in Chapman's that we would read to accompany chapters 3 and 4?
Does it not refer to it in the student study guide?
Oh, well, I don't recall. I'll check that though.
Chapter 3 is equipment for boats.
Well, hang on, guys. What they were saying is every version, the chapters may have moved around, so you have to look at it by subject, not by chapter.
Okay. Yeah, reference subject. Okay, so gotcha, engine.
All right. Does everybody see the configuration here? We'll get back to the other question. I'm sorry. Does everybody see where this is? A steering station. You know, this they vaguely call it a steering station because it could be a tiller, but it also could be a wheel. You know, it could be a spoke wheel, right? So you have your catch.
With all due respect, that seems to be the wrong definition on that slide.
All right. Well, let me go look it up. So, well, now we got to look it up, right? Well, that's what I got Google for. Who's got Google right in front of them?
What is the date and time of next class?
We're going to have it Central Time, 7 o'clock a week from tonight. So those of you that had that calendar thing, forgive me for sending that link, but it gave you the wrong hour because it gave everybody on their Google Calendar 6 or 7 o'clock. And if you lived in the Eastern time zone, it goofed you up because it told you 6 o'clock. All right. Well, now we got to know. 2 masts, smaller aft. After mast is ahead of the steering station. All right. Well, now we're going to look that up. I will send that out before next class. All right,
And the Zoom link is the same every session.
The Zoom link is the same. Yeah, everybody understand that? That's very important. The Zoom link is the same for every station. So Nick asked if we're just doing 3, we're doing 3 and 4. Some of the students may not have made copies of the manual yet. Okay. TCO this is not the TCO class. This is the auxiliary seamanship class. Any other questions which we didn't answer here?
Hey, Bob, just a comment. This is, you delivered what you told us you would deliver, and it matched everything. The books, everything just fit right. So at least it did for me. Thank you.
And so somebody who didn't, stay after and we'll try to figure out because I hope I didn't send you the wrong manual or something like that. Good. Any other questions? It's a little after 9. I know you folks there on the East Coast, it's late at night for you. Any other questions? I hope you guys have
one question.
Yeah, I got a question.
Go ahead.
Can you send out some of the questions and answers for chapter 1? Because the ones that you were reading, they were totally different. And I want to make sure I get it right.
And who is that? I got to write that down because we need to talk some more. Who is that?
James Richards.
James Richards. All right. Did anybody else have the same problem that James did? Because I don't. Hopefully not.
No.
James,
No.
Yeah, I think James, something happened with the copy that was sent to you somehow. So, but you stay here and we will figure out what happened there. Everybody, let's go down to your reactions. Kind of scroll your little mouse thing down there. And Paul did a great job. He's obviously an expert in this stuff. Let's give him a thumbs up. So right down the bottom where it says reactions, we sure appreciate him taking, the pay. You don't realize how high, boy, we make so much money teaching these classes. No, our satisfaction is helping you folks out there get ready for what you're going to be doing with the knowledge that we're sharing. Thanks, guys. Yeah, give them that thumbs up right on. I'm going to give you a clappy thing too, Paul. Good job.
Clappy thing.
I can't figure that out, but thank you very much.
Yeah, it's on the bottom next. Other questions?
No
Thanks for
question,
being
Bob,
here.
but just a comment here. At
ahead.
the beginning of each chapter, everybody was worried about whether they got to refer to Chapman's. It'll tell you whether you have to refer to Chapman's or not at the beginning of each chapter, the first paragraph. So if you read the first paragraph of each chapter, you'll know whether you have to refer to Chapman's or not. Hope that helps.
And
Excellent.
chapter 3 says everything is in the study guide. Chapter 4 refers you to chapters.
Exactly.
Excellent. And we're delighted to have some people that have specific expertise. And, we appreciate your input. Paul, any final comments?
No, I'm good. Thanks, guys.
Paul, thank you. Robert, thank you.
Thank you. Thank you both.
We'll look
Take
forward
care
to
now.
seeing you all next week at 7:00. Thanks for your time. And we hope that all you folks in Florida are safe with this bad storm in South Carolina and Georgia. Safe too. James, hang around, James, and everybody else. Thanks for being here, and we'll see you next week.
All right.
Thank you.
Goodbye.
Thank you.
Have a good night.
Good night.
Good night.
Good night.
Thank you. Have a good night.
Good night.
Good night.
Thanks
Good
for
night.
being here. Good job, Paul.
Thanks.
Where are you, James? All right, James, what happened here? How did we get the wrong book to you? Did you print out your book? Where'd you go, James? PRUNNOFT?
Yeah, I don't have a printer, so I couldn't print it out. But it was totally different questions that was at the bottom of the book.
All right, so show me the front of the book that you got there, James. That looks like the right book. Show me the questions at the end of chapter 1.
Okay.
Yeah, open your book to that page and let's try to figure out what happened there.
Yeah, I don't know. Let me check it out here.
Wonder if this thing will Photoshop some hair on my head. I could. Manuel, did we answer all your questions?
Yes, you did, Bob. Thank you so much.
Thanks for being here. Anselm, did we figure out the question that we had? It seems like he asked me a question right before class started. Did there, Anselm? You there, Anselm?
Yeah, these are the ones.
Yeah, let me slide it over just a little bit. All right. Yeah, put it right up by the camera so I can get a gander at it. Over to your left a little bit. There you go. So that looks like the same questions I got. You didn't get the answers correlating?
No, I filled out some of the answers I was studying, but I don't think it was the same questions that you had put, the ones that you were going over fast. So I'm not sure.
You want me to read them to you, James? I can read you the answers if you want. These many of these same questions you're going to see again on the final exam. So you do want to have a good record of the answers.
Okay.
All right, number 1, the answer is, and let me know if I'm going too fast. Number 1, the answer is strands.
Yeah, I had that. Yeah,
yes.
strands. And resin, right?
Layers of fiberglass and resin. Mm-hmm.
I have that one in. Okay.
All right. Well, why don't I say the number, and if you got the answer, you just read me what you got.
Number 2, I got gel coat. Woven.
So the gel coat is not, it's not part of the fiberglass. That's the gel coat. So what you're looking for, the woven, chopped strand.
Chops. Okay.
Mat and cloth.
Cloth.
CLOTH, like clothing, cloth.
Okay. Yeah.
How about 3?
3, I have two types of fiberglass construction are I have polyester and epoxy.
Correct. Number 4.
Okay. Number 4, There are too many substances added to the boat building resins. They are used to harden and fire resistant.
Good. There's also a couple things he said, which was control the curing time. Some will make it slow down a little bit so it has more time to dry. Others take less time. So it controls the curing time.
Okay, 5, I have male mold is known as the plug.
Good.
Okay, 6, I have a female mold is known as cavity mold.
Correct.
Okay.
7.
Okay, 7, I have raisin in the fiberglass strains.
They're looking for the same thing again, cavity mold. It's just kind of a
Oh.
different question for the same answer. Cavity mold.
On number 8, I have gel coat.
Yep. Number 9.
Let me just write them in. So yeah. Number 9, what did I have? I have metal and limidate.
So they're looking for male and female molds.
Male and female
molds, like a mold, like you're gonna make a mold or something, and then a laminate in between.
Oh, limidate. Okay. All right. 10, I got wood and balsa.
So foam plastics, plywood, and balsa.
Okay. Wood and what is it? Plywood?
Plywood,
And balsa. Okay.
Yeah. And foamed plastic. Foamed plastic.
Okay.
How about 11?
11, I had Imperious Marine boardings. I don't know if that's right.
Yeah, so it doesn't look, there's no rot or marine worms.
Marine worms. Okay. And no rotting.
No rot. No seams.
No seams.
Easy to mold.
Easy to mold.
Strong.
Strong. Okay.
And integral colors.
Integral colors. Okay. All right, that was 11. All right, so 12, I have the list of disadvantages of fiberglass boats is heavier in water. I don't know if that's right.
That's correct. And easy to cover shoddy workmanship.
Oh, shoddy workmanship. Okay. 13. I had, what are the 2 general classes? I have wood, hardwoods and softwoods.
Good. 14.
Okay, 14. 14, I had strength, decay, resident, and availability.
Good. 15.
15, I had strength, impact, and strength.
So, so fire resistant is another good answer there.
They're just looking for one, or they want a couple answers. So I'll probably give you.
Yeah, there's like 3 different choices they put in there on the slides. They're less noisy than all but wood, so it's less noisy.
Okay. 16, the disadvantage of steel for boat building is I put deterioration.
Good. 17.
All right, 17. I put corroded.
So there, it's like corrosion, but it has to do with electrolysis, where you have the weaker metal will fall apart because the stronger metal will pull in its electrons. So it's called to protect against electrolysis.
Okay.
It's like the old thing where you used to get the mustache hairs off there, the old electrolysis. I don't know if you're old enough to remember that, but
yeah, I'm 67.
There you go. 17.
Okay, 18. The list advantage is of aluminum for boat building. What did I put? I put imperious. I don't know if that's the right answer.
Yeah, it's like impervious. It looks like imperious, but it's impervious, which means the bugs can't get in there.
Yeah, imperious.
Impervious. And
19.
lightweight. Did
Oh,
you put light?
lightweight.
So it's impervious to bugs that'll bore into it, like little sea slugs.
Okay, 19. The list of disadvantages of aluminum for boat building up. Low melting point. I don't know if I got that one right.
Well, it conducts. One of the things they say is it conducts heats very well. So it's a heat conductor. So if one part of the boat is hot and you put your hand on it, the whole thing's going to be hot.
Okay. Heat conductor. Okay.
And noisy.
And noisy.
Noisy. All right. How about, there's a lot of answers for 20. Did you write them all down?
I wrote sprocket, rack pinion, gyrus, shaft, and hydraulic.
Gear and shaft, and then tiller. Did you get tiller in there too? Tiller's another one.
Yeah, tiller, drum cable, sprocket, rack pinion, gear shaft, and hydraulic.
You know where the stone pony is?
What's that?
James, have you ever heard of the stone pony?
No.
It's a bar there in Jersey. You're in Jersey, right?
No, I'm in New York.
That's where the boss used to play musical. Oh, sorry. Yeah, I was born in New York. Number 21. What do you got?
All right, getting close. 21. Okay, tiller system is the simplest.
Yep. 22. Yep. 22.
22. Shear. The side of the.
Good. 23.
23. I didn't get that. Called round. I'm not sure.
Is flare. It's easy to get the two confused, shear and flare. Flare like the old flare pants, F-L-A-R-E, flare, like a flare gun.
And what is this one? Flare? How do you spell it? S-L-
Foxtrot, F-L-A-R-E. You know, like a flare gun that you shoot flares up?
Okay.
First letter's like fishy, foxtrot, flare.
Oh, flare. Okay. What are the three basic shapes of the bottom of the boat? I didn't know. I didn't get that one.
So you're really gonna have to study this stuff, Richard, before you or James, before you come to class, because it's gonna take some time. It's all part of studying. So
I know. I haven't been
round,
feeling
flat,
good yet.
and V.
Round, flat, and V, right? Okay.
Spelled V-E-E. How about 25? Did you get that one?
No, I didn't get that one. Planning hole. What is the difference between displacement and planning hole? No, that one I didn't get.
So like a barge is a displacement hull. It moves through the water by pushing it out of the way. So it displaces the water.
Okay, displaces water.
And planing rides on top of the water.
On top of the water. Okay. All right.
Like rides it once it gets up to speed, the all right. How about 26? Did you get that one?
I didn't get that one. In the wood boat construction.
I'm gonna guess you didn't finish all the other ones. Is that how it is?
Yeah. Up to up to 30.
26. A shear plank.
Shear plank.
Piece of wood that goes above the shear plank, the shear plank, SHEER plank.
Okay. And 27, what is the difference between a trunk cabin and a raised deck cabin? I'm not sure about that one.
So a trunk cabin, if you think of the tugboats there in New York Harbor, the trunk cabin, it's above the deck, but it doesn't go all the way to the edge of the deck. So if you were like on the deck, you could actually walk around the trunk cabin, but the raised deck cabin, it goes all the way to the edge of the boat. So there's really no good way to walk around the outside of it.
Okay.
Two different kind of cabins.
The truck cabin is above the deck, and the raised cabin is the
All
small.
right, so look that up.
28. What are the limber holes? What purpose do they serve?
All right, so the trunk cabin doesn't extend to the edge of the boat. It's inside the. You can walk around. There's like an aisle. You can walk around the outside of it on the boat.
Right.
So there's a hole cut in frames next to the keel that allow the water to flow to the lowest point. So you want those holes in the boat. It seems like you wouldn't want a hole in a boat, but you want.
So limber holes.
Number
28. What are the limber holes? I can't hear you.
Holes because that's going to allow the water to drain.
Okay. 29. The use of two or more materials of the whole vessel is known as
Composite.
What's that?
Oh, I accidentally muted myself. That's what happened. All right,
Oh.
James, you want to finish studying these and get back to me if you don't find the answers for them? Because I mean, I shouldn't just be giving you all the answers here. You should be doing some studying on your own.
Yeah, no, I understand. Yeah. Okay. Yeah, so okay, there's a couple of them I didn't get, like 31, 32, 33. Well, the gross tonnage you said it was 100 100 or 40, they said something?
So 34, the total enclosed space calculated in terms of tons of 40 cubic feet. You there, Stafford? Is it 40 or 100?
No, it's 40.
Okay, so that's a typo in the book then. So it's now 34, the total enclosed space calculated in terms of tons of 40 cubic feet. So it's a volume thing. It sounds like it should be a weight thing, but it's a volume.
Okay. All right, so there's just a couple I didn't get here.
Yeah. Dig those out. They're in the book. You got to do the reading. You got to be ready for class every week.
Yeah.
Unless you're digging through and reading this stuff, you're not going to be really learning very much.
Okay. Yeah, I'm trying.
No worries.
Yeah. I'm not bad for a guy that don't even own a boat.
Right. No, I've got a now, but I didn't want to.
I don't even own a boat. I never worked on a boat. I worked for the New York City Fire Department. I can tell you how to fight fires and everything else.
Yeah, my nephew, he's working for Chicago Fire Department up there by O'Hare Airport. So God bless you.
Yeah, I just retired. Yeah.
Oh, congratulations. No, my buddy, he was a plumber for the city of Chicago, and now he's taking trips, he's retired. So I don't know if you're into traveling, but he was talking about traveling because you've got your ID. Did they get you an ID card? Oh, I don't have it in my pocket.
Yeah.
You get a card, James? So you can actually travel to military places, Armed Forces Vacation. I think it's AFV, because you're a volunteer with the auxiliary. You might have had that already with the fire department, but AFV, you could take different vacations around the world, like the Cayman Islands. He goes to this place called Muritz Resort. He loves it.
I want to go to my wife's country, the Philippines, and maybe retire. And I know there's a lot of boats and all this stuff. I want to know about this stuff in case I'm down there, you know?
Sounds good. Yeah, no, one of the guys at church choir sings with me. He's a fireman here in Aurora, a little town called Aurora. But, all right, well, thanks for hanging out with us tonight, James. I'm going to work with Stafford on some of his presentation for coming up next 2 weeks, I should say.
All
You're
right,
welcome to hang around, but it might be boring.
I'll review all these questions and answers again. I'll start cracking in the books. So,
Appreciate it. It's interesting stuff. Yeah, it's fun stuff.
The answers are in the chapter there, right? And I'm waiting for that other book from the Chapman book. I ordered it.